video we are going to discuss about physical design flow. Initially we are going to import the design and do the sanitary checks. After that we are doing the partition. Like initially we do the partition, after that we used to import the design and do the sanitary checks, and after that we used to do floor planning, power planning, pre-placement is nothing but we used to place the well tap cells, end cap cells, decap cells, right? Those are the pre-placed cells. And any large circuits also, like if macros also, we are placing the macros also, right? These are also comes under pre-placement. Placement of standard cells and modules, like inside a module there will be only the standard cells. And pre-CTS optimization is nothing but optimizing the netlist in a such a manner that reducing the gate count. If I had a let us take 2k gate count. If I had after optimization it may reduce to 1.5 gate count, so I am reducing the area as well as power as well as the timing path also, which we are checking, is going to reduce, right? After that CTS is clock tree synthesis. We are giving as we had both combinational and sequential circuits inside the design. So all sequential circuits need clock. So how do I give the clock? In a manner like if you take, this is a block, so there are some flops inside my design. These flops are placed like this. So I should give a clock in such a manner that, so if clock is coming here, it should be so the it should be in an equal manner. The time taken by the clock to travel from here to here, from here to here, here to here, like from here to here, here to here, should be same, so that the skew is going to be balanced and the latency will be equal and all these things. So difference between the clock from here to here is called skew. So let us take, if it is taking L1, if it is taking L2 to come from here to here, L1 is from here to here. So difference between skew is difference between L1 minus L2. So it is the arrival time difference, I can say. So that is the main thing. And coming to the L, what is L here? Latency. L1 is the latency for this flop. Latency of FF1. This is FF1, FF2, FF3, FF4. So latency L2 is latency of flip-flop 2. So that is what here. And coming to the other parameters, what we need to check was and so many parameters like crosstalk, glitch, all these things we need to check during post optimization. So why we are checking all these things is to ensure that my signal has good logic. If I'm expecting at output 1, it should come 1 but not 0. Due to this crosstalk, due to this latch up, there is a chance, there are so many other things, due to IR drop or all these things, there may be a chance of changing of logic. That is what we need to take care. And what we are doing is, in our flow, we after floor plan, what are the checks we need to do was, checks are generally due to power planning and like whether the power plan VDD VSS shorts are there, or utilization factor, blockages and macros checks, and macros are placed inside perfectly or not, like placement to the grid. So I can say it here. So this is the, so this is my this is the grid, let us take. so whether my macro is placed here perfectly or not. So it should be in a grid only, snap to grid, but it shouldn't come out of the grid. So if it is coming like this, right, there may be a chances of the that may be create a fabrication issue, or that may create a notch. This is a notch, the extra part which is there, right, that is a notch that shouldn't be happen. And macros density, how much it is occupying the space area, I mean. And cell density, cell density we check after placement. And legalization, whether it is snap to grid. Legalization is nothing but snap to grid only. So mm, and after that, um, macro to macro, so how much it is the macro to macro placement. If one macro is placed like this, other macro is placed like this, so how much it, whether the distance is small or not. So if distance is small, what we can do, what is the advantage? So the routing resources will be less. So my there is a less chance of congestion, there is less routing resources, and fabrication cost also will be reduced. So that is my thing. And easy to, this should be always placed near to IO pins. So if it is placed to near to IO pins here, if it is IO pins, so it should be placed near to IO pins. Why it is? So it is easy for macro port to macro communication. So if there are more number of signals, right, so if it is far away from the IO pin, definitely the signal going to be degraded. That shouldn't be degraded. So that is what we need to do. And all we used to create MMC files. MMC files are nothing but multi-mode, multi-corner files. So why do we create MMC? Yeah, triple MC. So multi-mode, multi-corner. So I need to close my chip at all the corners, right? So FF corner and SS corner, typical corner. And there are so many other corners. If you had the graph of that, so uh, it will be like this. So this is going to be some FF corner or SS corner here. And typical corner is in the middle, and the FF, this will be SS, and this will be FF corner. So we need to close my chip at all the corner. And P is the corner, and V is the voltage level. There will be, if my operating voltage is 1 volt, so 10% from this will be 0.9, and 10% 1.1. So 10% corners we used to take. After that, temperature is depends upon the specification, we can't say it. Minus 45 degrees to 125 degrees we used to take. So all these corners I need to close the timing, so such a way that I can say then it is my chip is my chip can operate at any corner or any point of time. That is what I need to take care. So that is the thing. And sorry. And coming to the post CTS optimization, routing optimization, and post routing optimization. So after routing, in CTS, after CTS we used to get setup and hold analysis. In here we used to check only setup time. From here we used to check both setup and hold time also. So that we need to optimize our paths in such a manner that, so we are going to discuss it in future videos, how to fix setup time and hold time during pre CTS stage and post CTS stage. So so I can say it here only TS setup time. Here we can do both setup time and hold time. After that, we are routing also, we used to have DRCs issues, LVS issues, and all these issues, and we need to fix setup time and hold time also, since we had actual routing coming into the picture and actual things coming into the picture. And so what we can do is to reduce the violation as early as possible. So if I got, let us take one violation, I got it in pre-CTS stage. So if I'm neglecting this violation here, so this may create a huge violation here. So I need to do good optimization at early stages of my design, so that I can't so that I'll be easily figuring out good chip design. Yes, that's what. And